Hello and welcome to som-itsolutions. My name is Somenath Mukhopadhyay and today I am going to teach you about the concurrent framework of Android. We will know about the nitty-gritties of the concurrency framework of Android, and we will also see how this concurrency framework can be used in real-life applications. So again, welcome, and I hope you will be able to get some good idea about the concurrency framework of Android after finishing this series of lectures. So let us start. What is concurrent programming first of all? By concurrent programming, we mean that there may exist different streams of computations in a large program which will run concurrently, and not only that, they will communicate and even interfere with each other. These individual streams of operations are called threads. Threads have their own call stacks, but they share other resources of the larger process where they are running. So given two threads T1 and T2, the following things may happen. T1 may finish before T2 starts or vice versa. T1 and T2 may run alternately. T1 and T2 may run parallelly on two different cores of a multi-core processor system. Which of the above options will happen depends upon a subsystem of operating system called scheduler. Having said about the general concurrent programming, now let me tell you about the Android concurrent programming. But before we start anything, let me tell you something basics of Android. When an Android application is launched, the Android system creates a thread of execution for the application. This is known as the main thread. This is also known as the UI thread because all the Android widgets used for this application run in the context of the main thread. And the interesting part is that we cannot touch or update this UI thread's widgets from a background thread, because the Android UI toolkit is not thread safe. Please keep this in mind that Android widget UI toolkit is not thread safe, because this is one of the main reasons why we need a concurrent framework for Android. Now let me tell you exactly what the UI thread does in the main Android program. The system does not create a separate thread for each instance of a component. All components that run in the same process are instantiated in the UI thread, and system calls to each component are dispatched from the UI thread. Consequently, methods that respond to system callbacks such as on key down to report user actions always run in the UI thread of the process. For instance, when the user touches a button on the screen, your app's UI thread dispatches the touch event to the widget, which in turn sets its play state and posts an invalidated request to the event queue. The UI thread dispatches the request and notifies the widget that it should withdraw itself. Now let me give you a practical example of why we need a concurrent program in Android. Suppose we want to download an image from a remote server over the internet. To do this, we need to establish a connection with the server and then start downloading the image, right? Now, if we do all these tasks in the UI thread, then the UI thread will remain unresponsive for some time, because generally most of the HTTP clients IO calls are part of blocking IO system. Hence, if the network is slow or the image size is large, then the UI will block and no events can be dispatched from the UI thread during all this time. From a user's perspective, the UI will remain unresponsive and frozen. The user may get the dreaded application not responding message as well, in which case he may kill the application. Of course, that is not desirable, right? To avoid such issues, we need to create concurrent programming in Android. In the concurrent programming, we will offload the long-running tasks like establishing the connection with the server and downloading the image, etc. to a background thread. Now, if we do all these long-running tasks in a background thread, then you must be wondering how the user can be notified about the different stages of these tasks, like download started, 50% downloaded, 70% downloaded, download over, right? And therefore, we need the concurrency model in Android. Using this concurrency model, we can not only very easily offload the long-running task to a background thread, but also we can notify the UI thread or the user about the different stages of the background task like download started or download finished, etc. This model is important because, as already discussed, that the UI toolkit in Android is not thread safe, and hence we cannot touch or notify the UI controller directly from a background thread. Now probably you are able to understand why we need the concurrency model in Android. In the coming series of lectures, we will study in details about the concurrency framework of Android. So stay tuned and thank you for enrolling in this training session. See you in the next lecture. Bye.